All right, everyone, welcome to day 4 of Launchable. Before we get to today's panel, just a shout out to our sponsor, JP Morgan, for helping us out, not just with the entire event in terms of sponsorship, but also swag and really getting behind this panel. We appreciate their support of the Seattle startup community. And when you raise a venture round for your foundation model startup, you should definitely consider them for venture debt. So that's the plug for JP Morgan, but we appreciate their support. And now it's my pleasure to introduce you to our moderator for today's panel, Sabrina Wu. Sabrina joined the investment team at Madrona in 2021 and is particularly focused on intelligent applications and the future of work. Prior to Madrona, she was at Vector Capital, a tech-focused PE firm in San Francisco. And she recently led a firm-wide deep dive on emerging investment opportunities surrounding foundation models, is the perfect person to moderate this exciting panel of builders and investors. So welcome, Sabrina, to Launchable.
Thanks, Mike, and thanks everybody for joining us today. I'm excited to be here today with Alex Ratner, Diego Oppenheimer, and Todd Hooper. I'll give a quick introduction on them, and then we could dive into kind of the topic for today, which is investment themes. So Alex Ratner is the co-founder and CEO of Snorkel AI and an assistant professor of computer science at the University of Washington. Prior to Snorkel and UW, Alex completed his PhD in computer science advised by Chris Ray at Stanford, where he actually started and led the Snorkel open source project. Diego Oppenheimer is a partner and CEO in residence at The Factory, which is an investment firm that is building and investing in the next generation of AI companies. Prior to joining The Factory, Diego was the EVP of ML operations at DataRobot and was also the CEO and co-founder of Algorithmia, an ML ops software that manages all stages of the ML lifecycle. And lastly, Todd Hooper is a seasoned tech entrepreneur investor, having spent over 25 years in the tech industry. Todd is currently a venture partner at Sequoia Capital, where he works with gaming-related investments and is advisor to over 9 gaming-related companies. Todd is also a serial entrepreneur himself, having founded multiple companies throughout his career. 2 of his most recent companies include VReal, which revolutionized gaming content by allowing you to navigate VR games without a VR headset tool, and Zipline Games, which is an open source game development platform. Thank you all so much for being here today with us, and really excited to dive into talking about investment themes. Awesome. So I think to start off, there's clearly a lot of buzz around foundation models today, and you all spend time in different spaces and sectors, kind of at different layers of the stack. And I'm curious, what areas are you guys all most excited about today? Maybe we could start with you, Diego, and then go from there.
Sure. So I think there's kind of like 2, I think people talk about them in slightly different ways. I think, one of the most exciting parts, I think it's kind of like the inspiration that a lot of these kind of foundational models have given to what I would call, like, at least in my career, like I've never seen so many hackers like going at it at once and kind of like around one kind of product or one style of product. So I think like a lot of imagination was like woke it up, and people are really thinking, how can I apply some of these large language models to X? And there's a lot of that thought process. I kind of look at 2 different areas. One, which I call kind of like AI UX defensibility, which is really interesting. People who have gone really, really quick to market, sometimes using, kind of some of OpenAI's models, which are, anybody can kind of tap into that API, but have created really interesting workflows in their UIs, have captured kind of the imagination of a much wider audience of people who've never really worked with ML models before. That's really exciting. I think that has kind of like one bucket, let's call it AI UX. On the other side, I think there's a lot of organizations who kind of have a little bit higher level of expertise on the ML side. I've been working with foundational models maybe for a little bit longer, and they can get some of these kind of like fine-tuned models and train their own models into like highly contextual to whatever the space is for that organization. That is another interesting area that I look at, because I think where you can actually look at the data inside a company and specifically kind of train some of these models on data specific to a company, it becomes hyper relevant to a person, hyper relevant to an organization. So those are kind of the 2 buckets. It's very generic, I realize that, but it's kind of like one of the amazing things about some of these large language models in particular, that they have so much applicability that, I kind of like bucket them into those two sides.
Alex, Todd, any thoughts on that or other areas that are more interesting or as exciting to you?
I come at it from a very practical point of view. So for me, I think DALL-E and Stable Diffusion kind of had the biggest impact in just being able to take anyone that, you know, maybe doesn't have artistic skill or anything and just sit them down in front of something and say, here, try a couple of prompts, and then kind of get them going down that path, becoming a prompt engineer. I especially like Stable Diffusion because, to the point that Diego said, it's something you can download and run and access the code locally. So it's opened up this little mini industry of people building scripts and interfaces and all these things off it. And so from my perspective, it feels like it's moved really, really quickly. And I can really kind of look under the hood and see what it's doing. So for me, the image-centric models have and the tools around that have been the kind of the real eye-opener.
Yeah, tons of stuff to say here. I'll cut some of the babbling, and actually we just ran a pretty deep in the weeds foundation model summit with a bunch of academic and commercial folks. A lot heavy overlap with this group here. If you want to go deeper into what some of what we're doing on the kind of the academic and method side and some of the perspective there. But I think at a high level, I mean, Diego, I'm going to end up copying. I'm basically going to end up kind of relabeling your buckets. Honestly, I think. And maybe that's not a totally, wholly unproductive thing to do, since there's so many, like any nascent, rapidly expanding field, there's just like a, explosion of different terminology. So, so that kind of, reduction, maybe it's helpful, but basically the same buckets. I mean, what you were calling the AI UX bucket, I think of, it's not the same thing, but kind of aligned with so I think about this split of kind of generative versus discriminative or predictive AI. And that frames a lot of how I think about it. So I'm not quite answering Sabrina, your question yet, but just as a framework, because we're kind of talking about that, right? So you've got generative AI where I want to generate a snippet of text or an image, and then you've got predictive or discriminative where I want to, I don't know, decide if there's a specific object in that image or if there's a specific type of offensive content, let's say. And I'll start by saying one thing that's very interesting to me is that intuitively and actually formally as well, generative AI seems harder. I mean, think about it. It seems a lot harder to generate an incredible image than to detect whether there's like a banana or a tank or an offensive, image inside it. But if you pair the kind of innate difficulty of the task or of the distribution, joint for generative or conditional for predictive, with the kind of bar for success to actually use it, it kind of flips, I think, right? So a lot of the generative AI applications, if I need to take 30 samples and mess around and edit the result to get the image I like, that's a wonderful experience. In predictive AI, that's a sub 3.3% accuracy rate, which is laughably below the bar for deployment, right? So that's kind of one thing that I think is a very simple point, but maybe under appreciated. And so I think in the generative space, it's really exciting to see all this hacking but especially a lot of, just going back to Diego's point, the kind of human in the loop processes, because these generative, the benchmark of generative is usually, can it be part of a human in the loop process practically? What it means to generate something with 100% accuracy so I can ship it automatically isn't even well defined, right? So it ends up being used in these, human in the loop processes. I think that's where it's gonna have the most success. And I mean, all kinds of awesome demos, but I think the real value is going to come from how do you get this kind of fuzzy success measure output that's maybe 80 to 90-ish, and you can't even measure it % correct, and put it into a really productive human in the loop workflow so that it accelerates folks, helps them, create art, generate content, build video games, etc. So I think that's like the really cool challenge there. And then for predictive AI, which is kind of the boring old area where, at least at Snorkel, we live, but it's also where a lot of the enterprise value lives as well. You're trying to automate or predict or label something. It's all, again, I'm just saying the same thing as Diego. I'm sorry, you stole all my content. I'm broke for the rest of the panel. It's really all about adapting, or to use Diego, your terminology, contextualizing. And here's where I get to, I guess, more directly speaking my book, but it comes down to the data and the way that you supervise the models. So That's something I think is really, really exciting. A lot of what we've talked about over the years, both relative to foundation model and not, over the last 8 years, this idea of data-centric AI development versus kind of traditional model-centric development. It's not an either or, you do both. But the thing that I think people don't fully absorb yet in the ML and ML ops world is that foundation models, coming into full swing like they are, it's really accelerating the death of model-centric development. And I'm saying that with some intentional, exaggeration, just to make it more fun. But practically from a user perspective, how are you going to tweak the parameters or the architecture of some 500 billion parameter model because it was getting a certain type of contract or a certain type of image incorrect? You have to use data or prompts or supervision to do that contextualizing and fine tuning to get it to that 99% to actually ship. And so there's all kinds of cool stuff with prompting. There's all kinds of cool stuff with reinforcement learning based supervision. A lot of this does usually, for best performance, come down to labeled training data and fine tuning. So I think there's a huge amount of stuff there. We're obviously operating in that space, but there's a ton to do there. How do you take these amazing things that can generate mind-blowing demos and content and actually use them to build shippable predictive AI that's contextualized for those really specific highly bespoke, high accuracy settings like Diego talked about?
Yeah, and I think we just started talking about this, but the way I see foundation models more broadly is there's kind of you guys were just saying that there's 3 broad categories to the stack. There's the model layer that sits at the bottom, the middleware layer, which Alex, you were just talking about, which includes some of the fine tuning and the prompting. And then on top, there's the application layer. I'm curious if there's any buckets that you think should be added or, to this stack. And then within each of these layers, where do you see the most innovation? And what are you most excited about within each of these layers? I think, Alex, you were just talking about maybe the middleware layers. So I'd be curious to hear more of your thoughts around that. And then Todd, I know you focus more, have more experience on the app layer, so kind of curious to hear what you think about that. And then Diego, would love to hear both thoughts or model thoughts as well.
Yeah. I mean, I could be quick because I basically already said my whole spiel and I took too much time already. But basically what I was saying before, and my viewpoint is, I'm exaggerating to make it more interesting, but I think that the model layer is going to get it's already fairly standardized. Everyone's using the same model architectures. Still a couple last mile kind of infrastructure tricks that mean a lot, right? But a lot of the models are standardizing, right? So I think the middleware layer, and if there can't be if we can't have our own data layer, which obviously I would push for, and then I guess data is a sub piece of the middleware layer. It's fine. Middleware is sexy. So data goes under middleware, and then I think that everything there is really exciting. Actually, I think Ludwig Schmidt was on a panel earlier, and there's some students that we both work with, putting out some cool data-centric foundation model contests that are going to get posted soon. So I think there's a ton of stuff there, and then the application layer for the generative piece. So for predictive AI, I think it's all on the middleware, and within that, the data layer. For generative AI, I think it's all on the application layer. And I think the model layer we're gonna see what happened to, pre-foundation models, which is massive kind of standardization, which is gonna be awesome for the field, but there's gonna be less secret sauce there, is my guess.
Yeah, I mean, to the apps point, obviously I'm all about the apps. Games are very labor intensive, so having an application that can take what a person is doing and just help them do it much, much faster, is pretty incredible. And we've obviously seen that, you've seen a lot of generative AI image stuff. However, one thing that kind of occurs to me as I look at that, and as I've looked at it, really when you want to look at real labor savings in games, it comes down to 3 groups of people: coders, artists, and QA. And most artists, when you have big game teams, they're working in 3 dimensions. They're not working on just concept art. And so I actually think there is a space for people to build new foundational models around 3-dimensional data and around animation data, because that's very labor intensive. The current approach is to take a 2D model, if you look at Stable Diffusion, it's based off the Lion data set. That's all 2-dimensional data, and then they're trying to infer like a point cloud or something from that. I don't know if that approach, from what I've seen, is actually going to hit the production quality that you need for interactive content. And so I think there actually is space for someone to come in and say, I'm going to take a different approach. I'm going to find a big data set of really good 3D information. And then that would become a new kind of foundational model that people would be able to use for the specific kind of use case that I'm interested in. So sure, apps great. If you have an app, I'd love to have a look at it. But there's actually space for more ambitious things as well, because that foundation model could be a proprietary moat around some technology.
So I'll take a little bit the hot take style side of this, and I think actually infrastructure is actually going to be going through a quite a bit of creative destruction on this space. So if you start kind of think about like basic kind of systems architecture, training these models, I mean, it's pretty known, you know, like massive amounts of data set, massive amounts of GPUs. You need, you know, new techniques. So there's tons of new stuff coming out, how to train it on kind of like low data pipelines or kind of like, you know, kind of like standardized data pipelines distributed across the globe. There's a cost function, right? So like when do these models, especially kind of like the baseline large ones, you know, become economically unfeasible to be run other than, you know, almost like a nonprofit. So I think there's that, you know, kind of, you know, part of it where I look at, I think I totally agree with Alex on the data part of this has become so much more important, right? You have to tune these data sets. You have to kind of inject like almost like perfect data sets, or create things for what you want the result to be. And so you have to spend a lot more time kind of, you know, kind of pruning and kind of creating these like data sets before you go into training, because already these training runs, even with the newest techniques, cost a fortune, and getting them wrong is just not, you know, like economically will turn around your entire business model. I think on the inference side, it's actually really interesting. So like we're looking at models that just don't fit on traditional GPUs. And if you go just look at just baseline, like where you can make these available in cloud providers, they cost a fortune to run. And the actual latency we're getting is actually quite bad. And so if we start thinking about new use cases where you want to get to millisecond, you know, inference time, when you want to get to nanosecond kind of latency, what I want to fine tune models inside my organization, because I have a global presence and I need to not only fine tune the model, but then redistribute the entire new foundational model to across the entire globe so I can get that low latency. These are massive, massive problems that are just not solved, right? These are not solved today in terms of the infrastructure required. And so, you know, as a person who spent like almost 8 years doing inference for machine learning models, like we're in a complete like creative destruction moment where it's like everything needs to be rethought, like how we do the architecture for these, you know, infrastructure, how we do inference, how we run these models, how we set up the pipelines so that you can actually have these experiences is I think is being, you know, relooked at from, you know, from the ground up. And it's fascinating to see, but there's a ton of innovation that needs to happen because, you know, I want, I guess, in nanosecond, millisecond inference times for models that are highly tuned to me. And so is that smaller models? Is that faster inference time on larger models? Is that distributing them? Is that breaking them up? I don't know. But there's a ton that needs to be figured out there. Maybe it's a combo of all of them. So I think there's a really exciting times on the infrastructure space. It's a question of, you know, who's attacking them and how they're being attacked.
Yeah, that's interesting. And do you think that there's any innovation to be had kind of at the silicon layer as well and more optimization there? Or do you think it comes more from, you know, fine tuning at that middleware-ish layer, or maybe a mix of both as we think about it? And then also, you know, some of it comes with the model layer too. But curious if you guys have thought about the silicon kind of, which sits, I guess, at the bottom of this all, if there's any room for opportunities there.
Yeah, I think there's a ton. I think, you know, the way I always looked at hardware was commercially available, right? Because if you're really trying to do like, I mean, it's great to get like, you know, very specific hardware for very specific use cases, build an entire stack. There's a ton of value in those kind of like verticalized kind of full appliance solutions that can get to. But if you really want to be good, you know, if I look at, you know, I look at kind of, you know, we commoditize compute, we commoditize storage, we commoditize network. It very much looks like we will commoditize some baseline of foundational models, right? Like kind of like, and you will be building the next generation of applications. You'll buy compute, you'll buy storage, you'll buy network, you'll buy some sort of foundational models, you'll build your application on top of that. So if that's, you know, kind of true, then where you're fine tuning those models, how you're actually, you know, deriving from those models a secondary workflow, you're going to want commercially available hardware. So yes, if there is specialized chips that accelerate that whole thing, that are commercially available, that they're widespread, that I can just go buy in the same way that I buy my normal compute, then absolutely, I think there's a ton of that. I think when it becomes like very specialized chips that I need to like kind of like run my own data centers, that's just an adoption impediment that exists today. And we see that kind of with not a ton of adoption, at least again, I have a slightly biased and smaller view of the world, but like it's not like there's people are running towards FP. There's a lot of innovation in that space, but they've not become kind of ubiquitous in the machine learning world. You have CPUs and GPUs for the most part.
Yeah, I don't know, Todd or Alex, if you have anything else to add to that, but if not, happy to ask for questions. And if folks in the audience also have questions, please feel free to shoot it in the chat or raise your hand, and happy to facilitate that. We'll leave some time at the end for Q&A, but please feel free to jump in at any time. So as I think, yeah, please, Alex, go ahead. No, go ahead.
I think so I agree with Diego that the a lot of the infra is going to get blown up and reimagined, right? I do think a lot of the infra and a lot of the kind of model serving and inference infrastructure that Diego, you did a lot of work building and pioneering, is actually going to stay for a very long time, because you can deploy these foundation models, or you can use them to build smaller deployable models. And with our work and our customers, we're supporting both, but we actually we work with larger enterprises, right? So we work with like 5 of the top 10 US banks, and it's gonna be a little while before they're gonna plug a large foundation model, which we still barely understand, even aside from cost, into a big mission critical application. The cool thing, we released a use case with some of our academic partners with us recently, and there's lots of results from Microsoft recently as well. Some coming out from some UW students and Google also soon. But you can get the same or sometimes even better performance from a radically smaller model. So you can use these big models. This is often called distillation, or you can think of it as using foundation models to to teach or label data. But either way, that's a strategy that we think is going to be a lot bigger in a lot of the enterprises around these predictive AI applications. So I think the existing MLOps tooling, and also the governance procedure, because that's a big thing in especially regulated industries, a lot of that is going to remain, and it's going to be about how can we use foundation models to accelerate the development of smaller, more traditional models, versus how do we blow that all up, at least in predictive AI. That's my hot take, but it's like a boring hot take. I'm hot taking that we're actually going to not move as fast in some areas, right? But it has interesting implications for how we build.
Yeah, and I think, today there's obviously a lot of buzz around foundation models, what you can do with the models, and then the apps that you can build on top of them. And I think that it has caused maybe a sense of, maybe overhyped is not the right word. Some would argue maybe this whole thing is overhyped and maybe it'll blow over. I don't believe that over time, but some people would argue that. So I'm curious, from your guys' perspective, what do you think has been the most overhyped in the world of foundation models? Be that from a technical perspective of, actually these models aren't good at certain things. And, we think that they can do these things, but they actually can't. Or maybe it's from the app layer saying, there's 100 copywriting companies out there. How do we differentiate? Like, where is there maybe too much hype, and where should some of these founders have some caution when they're thinking about building? And then just understanding why do you think that might be? Maybe we can start with you, Todd. Yeah.
The big caution for me is still the IP issue is pretty much unresolved, right? If I come up with this fantastic generative image and I start making a whole bunch of variations of it, and then I look down in the right-hand corner, I see, oh, that looks like an artist's signature down there. Where did this come from? Now, I know I can go back to the data set and try and look for that artist, but clearly artists have reacted, and rightly so, pretty strongly to some of this stuff. So there's still this kind of open issue around this, which some people are saying, well, there's no legal recourse, but I think we're going to find that out really quickly in the next couple of years, because people whose art was brought into the training data, they're not happy about it. So that to me is one of the areas where I'd still be a little reluctant to go with a full commercial release of something based on generative art.
I think it's a great point. I like, one kind of analogy people have been drawing is that these are, prompting a foundation model or using it as kind of like, it's like kind of like a new kind of query for a new kind of database. And so, some of this is just truly miraculous, fully, very, kind of very novel creation of data, but a lot of it is kind of, almost like search and retrieval. And so I think it's a big question of how do we remunerate and acknowledge where that data came from. There's also other things that maybe this makes me think about, which is, again, it comes back to the data quality source, but a lot of these things that rely on these big open data sets, some people are concerned, it's not that crazy of an idea that we're going to start generating so much content on the internet that's from foundation models, and so you're going to have this degenerate spiral where all their data they're training on is generated, and what happens then? That's not as that's a little bit more pie in the sky, but it's not that far out actually. And then I think the other thing I would turn to is just, it's like a very very high level point, but just I think people always underestimate the last mile in machine learning, and so you can get an eye-popping demo that's and just let me take a step back. I don't think that the progress we've made is overhyped. I think it is incredible. I think it's, look over it at look on the academic side where it's turning a lot of like ML theoreticians into natural scientists, just poking it and prodding at these, there are jokes about how the latest batch of papers in academia, it's like went from like, here's this formal theory of something to, I prompted it this way and it said this silly thing and I have no idea what's going on. Like there's incredible emergent properties. There's something real going on here, but that's still, it's always the last, the last mile, right? So are we kind of, in a self-driving scenario where we're actually like, there's something real, it's doable, it's going to happen, it's very, we're very far, but we may critically underestimate that last mile. And in some cool use cases, it doesn't matter because it's good enough to just, get to 80%. And I think that's the kind of generative side where a lot of, I think that innovation is going to happen. I'd say, I guess for founders in the foundation model space, if you're not aiming for 80%, if you're seeing 80, 90, 95%, and you got to hit 99%, to ship, I'd be wary of how long exactly that's going to take, right?
Yeah, I actually, now I get to agree with you, Alex, on this one. But so here's the way I've been framing it as like, what's the affordability of the use case for something being wrong, right? And so like, and really looking at everything that you do. And so, why I'm excited, why I think it's not overhyped at all. Like, I think, if you just look at some of these like large language models, some of the generative AI side, you say, this is about augmentation of human workflows, then there's nothing overhyped about this. It's amazing. Like the productivity that we're getting out of doing some of these things, just the suggestions, the ability to say, hey, get me started on something, let's go to, and then now I can actually go in and kind of use my best judgment to finish it out, do the last mile, not the last mile from an infrastructure, what Alex meant, but from the last mile in terms of delivering the workflow. There's nothing overhyped about it. I think it's actually quite amazing. I think if you start looking at it as like, okay, we're approaching AGI or singularity and like these things are going to run on their own and I'm not going to need the humans and they're going to replace it. Like, I think that is completely over exaggerated and not really there. But the interesting thing from my perspective, I'll go back to what I call like that affordability. Like there's use cases where you can be wrong. Hey, I'm giving you a suggestion. Just think about my favorite example of this is if you have in Gmail, like, it sometimes gives you suggestions on how to finish it. So sometimes it gives you a good suggestion. Sometimes it gives you a bad suggestion. You don't really care. If it's great, you hit tab, it's done. If you don't, you just completely ignore it. Nobody's pissed, right? Nobody's pissed about that. So affordability, super high, right? Amazing use case. Even if like 1 out of 10 times I give you a suggestion that finishes my email, I've increased productivity for that person. You multiply that over how many of emails that you send, amazing productivity gain for a human. If I came out and said, hey, and there's something, he's like, I get an automated text message being like, we looked at your things, and it's like, we think you have cancer, and that's wrong. Really, really bad, right? Like super low affordability to get that, wrong. And we're quite a way to Alex's point around that 990 prints. So if you actually bucket use cases and you say, hey, I'm going to use a bunch of this technology for high affordability, and affordability to be wrong use cases, it's amazing. I mean, it's like literally sky's the limit. You can apply this to everything. I think that's what you're seeing. You're seeing this explosion of people applying it to different workloads of augmenting humans. And I don't see an end to that. And it's really exciting to see that. I think once you start going into, again, what I call the low affordability use cases, there's a lot more caution. We're a lot farther away. There's a lot more work that needs to be done before we can actually get there. So that's kind of how I break it down.
Yeah, the canonical example of that is Tesla, where we've been 6 months away from a self-driving car for 6 years. And of course, in a vehicle, you can't afford to have that level of error.
Yeah,
I totally,
oh, no, sorry.
no, please go ahead, Alex.
I was just going to I don't want to make this the panel boring. I was just going to plus one Diego and Todd's points. Diego 100%, like that's the divide, right? That's like the like we often refer to those like zero base, or anyway, I like your affordability terminology. Like that's the huge difference, right? And then Todd, your point about self-driving. I mean, I think there's a lot we can probably learn from looking at self-driving and kind of where we've and actually my little brother just started working for Waymo, so I'm not anti self-driving either. I think there's incredible stuff going on. He took my parents in a car recently, maybe today even. So I have to be very bullish on this, right? But when you look at what's keeping it at like it's 6 months away for this long, I think one part of that is that people maybe who are further away from it think, okay, we're at like 90%, and if we could get to 99%, then we'd be there. And I feel like we're more at 98 or 99%, but we have very little formal understanding of where the 1% error mode is. And so that's where we get to interpretability, right? Where, if these foundation models, we don't even know how to interpret or guarantee kind of where their failure modes are going to be. And so when people see that they're not at 80%, they're at 90, 95, whatever, they're like, oh my God, we're here, we crossed that bridge. But that's not the thing that gets you, right? In these, to use Diego's phrasing, low affordability use cases like driving a car or diagnosing a patient or making a loan decision. So it's kind of one of those things that we have to kind of correctly estimate.
So I just want to I totally agree with everything you guys said. I won't plus one again, but I like the framework that Diego started to lay out. I'll read out a couple of questions here from the chat. I think you guys can see them as well, but I'll read it out for the group. Ton Lee asks, will the infrastructure value be captured most by hardware, software, co-design companies if compute is the bottleneck? Curious about how much additional value could be captured by a pure software offering on top of a specialized silicon offering, maybe the governance or observability.
I mean, I'll take a swing at it. I think one of the interesting things in, again, maybe some PTSD for running an ML company for so long, like you really want to get as close to the value realization as possible, right? If you can't attach yourself to the value realization of a use case, it's very hard to justify your existence. And so that might be, kind of like being able to, in the monitoring space, see the failure modes, allow companies to like kind of adjust, get actually the higher accuracy, whatever that looks like. You're attaching yourself in some way to the value. It's in the, kind of like feeding new data sets, training new data sets, finding, kind of like pruning new data sets. You're actually increasing either accuracy or the workflow that can actually attach yourself. You are actually attaching yourself to a value like, point. So I think those are generally things like on the inference side, like, the decision, let's talk about the kind of like predictive, the old boring predictive that I spent so much time on that Alex talks about, like at the end of the day, what happens from a prediction, right? There's a decision that gets made. There's a process that gets kicked off or something automated that happens, but that's where the value happens, right? Like that's actually the capture of value of that, next best decision, prediction, whatever it is. It's not in actually like spitting out the probability, because that's really what's coming, the number, the coefficient that's coming out. It's actually about what you're going to act with that. And so I think the answer, it's a little bit of hand wavy, but I'd say like wherever you can actually capture that value realization, is important. And, that's what you kind of like need to, you need to be able to always attach yourself back to that value, no matter where in the stack you are.
And I'll read another question. I'll do a couple of the chat questions, then see if anyone has thoughts. So, judging if the content created by AI is still highly manual, which we call human in the loop, will some company develop a model to make human-like judgment on a few different dimensions, coherence, correctness, and accuracy for generated content, similar to the GAN idea?
I think personally, the human in the loop generative stuff is the most interesting, right? Like just generating a whole bunch of images from prompts is great, but I want to actually be able to go deep and be able to recreate something that I created earlier. So I think that's where the kind of interesting tools that I've looked at are, that they are more advanced than just the kind of, if you think of like DALL-E and ChatGPT, they're almost consumer-facing tools. They're very simple. They don't have a lot of state. They have some very simple inputs and simple outputs. You know, the sort of thing that I think is more interesting is a professional level tool that lets me actually have a little bit more insight into what's happening and then recreate that on demand.
Yeah, I agree with that. And then just to this comment specifically, I mean, I think there already are, I don't know if they're companies yet, but product or, you know, models or projects where you're trying to classify authenticity of you know, a content, right? This could be kind of with zero information. So I guess, you know, formally adversarial, right? You don't know where it's coming from. There's also a bunch of work on, you know, watermarking so that it's collaborative, you know, you're embedding some watermark so you can detect this kind of thing. I think there's a lot of interest there. And, you know, and I think that actually probably will be an interesting area for, you know, there's just a lot of areas like education, like content creation, where you're going to want to know whether it was, you know, human or, unless we have a major culture shift, right? You're going to want to know that. And because there's going to be tons of development of new foundation models every day, then there's going to have to be tons of development of these, you know, detection models. And that seems like it's, you know, at least a cottage industry, if not something way bigger. But, you know, whether you can, I don't think you can ever fully remove the human in the loop in complex scenarios. And technically, usually when you have these kind of generative adversarial network type, like even in GANs, if you're looking, at least in my my boring predictive world where now I've cemented that I live, you know, the high performance is still from semi-supervised approaches where the GAN component, you know, gets more boost from the labeled data, but you're still, you know, in this case, labeling data, or you still have a human in the loop. So I think these can reduce the number of touches needed from a human in the loop, which I think is really exciting. I still think for complex, you know, for complex decisions, it's going to require human in the loop. And so speeding that up, maybe there's exciting stuff there, and that kind of captures a lot of what many of us are trying to do. Replacing, I'm you know, highly pessimistic on for very, you know, core reasons.
And so do you think, I guess just touching on that a little, do you think there are any use cases or applications where it would make sense to remove the human? Like, are there certain things you would trust these models to do, and maybe you don't need that high accuracy? It's a very, very simple task. Like, are there any kind of examples of that you guys can think of?
So I guess I was responding just to the like models that evaluate the models. Now we're getting deep in the weeds. So I think, like, you know, Diego covered really nicely the, like, where would you trust these models, you know, without intervention? Well, really, you know, so, you know, high affordability, like you can afford to make a mistake. Although a lot of those high affordability situations are exactly because there is a human in the loop, right? So I don't know if that counts, right? Actually, you know, autocomplete or autosuggest is a great example, because that's the classic, I guess, small language model example, right? You know, I remember a decade ago doing, you know, my intro to natural language processing course, and guess what? We talked about language models. We didn't say large language models, but, you know, auto completion was the original use case, you know, for decades, right? And it's because of that affordability principle. Then if we're specifically talking about models that try to like judge other models, I think you can do that maybe for some things like plagiarism detection, or authenticity detection or something like that. That seems like a use case that has demand. But in terms of more complex decisions, like, you know, Todd, maybe in your space, you've been using an example of like crafting a video game. Like,
I think the obvious one for me is QA, right? QA is kind of a pretty random process in games anyway. So some of the QA stuff that I've seen where you train an agent to play the game, but it's predictive in that sense. You know, if you've got 100 agents playing the game and 25 of them get stuck in a corner, does it really matter? No, because you've still got data from some percentage of them coming back, and you can see, you what they did. And also they're doing other things, even though they may not be playing the game correctly, they're still exercising the systems and exercising the back end of the game stack and things like that. So that's one thing where, they might actually behave more like humans. My wife complains if I play a game and I fall asleep, she'll come down and find me, my character standing against a wall. The AI could probably do the same thing, right? And that would still be valid, even though technically that's a failed QA session.
I think actually it's not just in games. Actually, I would expand to QA and pretty much any sort of workflow whatsoever, right? Because in most cases, the baseline you're trying to beat is finding errors in a random sample.
Yep. Yeah.
Right. So
Yeah.
you're picking a random sample. You're trying to find errors. If you can find better errors, if you can beat that, then why wouldn't you just go, and let that loose on, on whatever. So I think but that is a super high affordability scenario, right? Right? Like I would qualify it strictly inside that bucket.
Yeah. I see one more question from the audience. I know we're coming close to time too, but I'll read this one out. One of the surprising things about large language models for me has been how general tokens can be languages, code, actions, etc. What are some of these tokens? What are some types of tokens do you think are unexplored in generative models right now?
There was actually maybe a year or two or 3 years ago, maybe there was a fun reading group at University of Washington on and this wasn't what we weren't talking about foundation models, and it was just embeddings, but embeddings over databases, right? And in general, you can. It's a great point. Like this basic self-supervision heuristic of train the model to predict what words are occurring in a window or whatever metric or objective you're using. It can work over arbitrary graphs, over arbitrary data structures, databases, et cetera. And so, a graph is probably a nice place to start, right? So there's a graph that's just a chain of tokens, but you can think of a graph of actions or of decisions, or, it really just comes to, do you have a gigantic graph, like a gigantic one to learn from? So I think it's a great point that, we're already seeing it with multimodal, but there's a huge expanse of possibilities for how you can apply this kind of self-supervision, but you need like a crap ton of data. And so that's, if you can find a data set that's like some, at an abstract level is a graph, then you could, and it's gigantic, then you can probably train a foundation model over it. And that is, I think, super exciting. So then it's just where are those gigantic data sets or graphs?
Great. I think we are coming on time. So I have one closing question for each of you. I'm curious, for all the builders in the room, any last piece of advice, anything that you would offer for them, for people that are either, starting from the ground or maybe trying to embed some type of foundation model research into their applications, any advice?
I think there's room for new, interesting models in areas that haven't been covered. I already mentioned three-dimensional objects. Whether you're using that in games or 3D printing or industrial design, regardless of what the format is, I haven't seen a ton of real activity there yet. Everything seems to be 2D, and they're building 3D out of 2D. That is super interesting. And then, in general, I like to find companies that are building something where there's someone who's a subject matter expert that can go pretty deep on it, and they can move pretty quickly. Some of the AI companies are so general, it's really kind of hard to determine who the subject matter expert is. So that, if you're going to go into a vertical industry to build something that's going to save people money, you probably should understand that industry or have someone associated with your company that understands it very deep.
Don't forget the data. I'll stick with that. Don't forget the training data. At least if you're anywhere where you need to do that last mile tuning.
I'll go with I'll give you the generic one on the general builders. Like, I think you can only go into some of these things if you're truly passionate what you're doing. This kind of goes to, like Todd says, around like the subject matter expert, but like, even at the speed that everything's moving here, there's no, it's not a quick turnaround on anything you do. So if you're diving in, and like, and for most times it doesn't mean that you have to stick to one thing forever, but it's a long haul, project. And so having that passion, I always ask the same question, which is like, do you want to work on this for the next 5 years? Do you want to work on this for the next 10 years? because that's essentially like a true question you have to answer when you're building something like that. And a more practical perspective, I think speed matters right now. So if you buy the whole like kind of like reinforcement learning, which you should, by the way, like human in the loop, kind of like building out the workflows, you know, kind of like getting inside the workflow, whatever you're touching, building the workflow and kind of in penetrating that, being able to get some of those feedback loops and build upon that is super important. And so there is somewhat of a first mover advantage in some of these spaces where if you can capture that workflow, it's going to be a huge advantage, even if you don't have at the moment the ML expertise. I'm not saying you don't need it later on. I'm saying you don't need to go build out kind of that muscle, but like you will, you know, that first mover advantage is really around workflows and kind of getting in and getting quick and then moving. So I think speed matters.
Well, thank you guys. This has been a lot of fun. Appreciate you sharing a lot of your insights today, and thanks everybody for tuning in.